like many of these kinds of problems, we've seen these all year. We're given a geometry situation up here, where we've got some lines and angles and whatnot, and we've got to come up with a geometry relationship that's going to allow us to build an algebra equation that we can solve, right? And we're trying to solve for x and y here, right? So can anybody see what's an example of one geometry relationship that we could build an equation for? Michael? Okay, good. 1 and 3 are congruent, aren't they? Because they're corresponding angles. Very good. And we know that if parallel lines are cut by a transversal, we know that corresponding angles are congruent. Good. So there's one equation that we can build. So let's see, 1 and 3. So then we're going to get 16x minus y minus 13 equals negative 5x plus 2y plus 95. Okay? So we got an equation. Now that's pretty ugly. Can we clean up that or simplify that equation? What can we do? Okay, let's combine like terms. How about if we add 5x, let's subtract 2y, and see what happens if we do that. So those cancel. 21x minus 3y. Okay, now what about the other stuff, the numbers? Let's go ahead and push those to the other side. You'll see why here in just a little bit. So if I add 13 to both sides, 108. Okay, 21x minus 3y equals 108. Good. Okay, so there's one equation. Now, the question.
Okay, do you know how you just minus like 2y and minus 5 the other side?
Yes. Mm-hmm.
I thought you were supposed to do like 3 on the one side, like 3 on the other side.
So okay, so why didn't I put the numbers over there too?
So like, how come you didn't minus 95?
Okay, right, exactly. Subtract 95 and get 0 on this side. I could have. I very easily could have, and that would have been just fine. We're going to end up wanting to put the numbers on the other side eventually, and I think you'll see why. But at this point, we don't know. I mean, we would have been just as good having negative 108 on one side, 0 on the other. Would have been fine. It would have been perfectly fine to do. Okay, now let's take that equation right there. Can I solve that and get answers for both x and y? I can't. Can I? How come? Somebody try to articulate for me, why can't I? What's the problem? Why can't I solve for both x and y in that equation? Okay, they're on the same side, and I've got two variables in only one equation, right? Our rule is we have to have, in order to solve for two variables, I need at least two different equations. Now, would you agree? I'm not going to actually write this out, but just watch this for a second. If I were to isolate y on this side, get it by itself, wouldn't I end up with x's in my answer? Right? And if I were to isolate x on this side, I would get y's in my answer, right? Okay, so that, and I don't want that. I want numbers for both. So I need another equation. Can somebody see from this picture up here another angle relationship that we could come up with? What do you think? Yes, ma'am, please. Okay, so angle 2 plus angle 3, measure of angle 3, would equal 180, because they're a linear pair. Good. There's another relationship, right? So let's write that one down. So I've got this stuff right there. So negative 8y minus 5x plus 25 plus angle 3, measure of angle 3, which is negative 5x plus 2y plus 95 equals 180, right?
Yep.
And I can do the same kind of stuff. Now, do those parentheses really do anything for me there? No, they don't. I get rid of them. The only time parentheses are useful is if I'm distributing something over the parentheses or I'm multiplying stuff. But nothing's being multiplied there on the left side, right? So I can just get rid of them. So if I combine like terms on the left side, how about the x's? I get negative 5x plus negative 5x is negative 10x. So I can get rid of those. Negative 8y plus 2y is good. Negative 6y. Let's get rid of those. 25 plus 95 is 120. Equals, get rid of those, equals 180. And then last step maybe would just be to, what, subtract 120 from both sides? Okay. Or I could subtract 180, either or. Let's subtract 120. So if I subtract 120, I'm just going to get 60 over there. Okay, so I've got two equations now, right? Let's call, here's equation 1. There's equation 2. What if I gather those together, like so? There they are, right? Okay, that ought to look familiar. Now maybe you can see why I put the numbers on the other side. Isn't that starting to look an awful lot like some stuff we did at the beginning of the year? Yeah. How do I solve a linear system like that? Okay. Okay, I could try to use elimination. Try to multiply one or both of the equations in a way where I could get either the x's or the y's to cancel, right? Right. So I need to write this a little smaller. Oh God. 21x minus 3y. Okay, now, does anybody have a suggestion? What could I multiply? Yes, sir. Nicholas.
Multiply the top by positive 2 and then multiply the bottom by 1.
By 1. Okay, so the bottom we're going to leave alone. Now, I almost agree with that. Now, what you're trying to do is get the y's to cancel, right? So if I have a negative 6y on the bottom, what do I need to have on the top? Positive 6y. So I'm going to multiply by negative 2. There you go. Okay, so bottom we'll leave alone, top will multiply by negative 2. If I distribute a negative 2 all the way through, what am I going to get? Drew, what do I get on both sides if I distribute a negative 2? So negative 2 times 21x is negative 42. Okay. Negative 42x
Positive 6.
plus 6y equals, that's a harder one. What's that? Okay. Okay, on the bottom, stays the same. So the y's cancel when I add those up, right? Okay. Negative 42x minus 10x. Negative 52x. Okay. Ozzy, you getting this? You getting this? Okay. Negative 216 plus 60. No, that's negative, that's positive. Yeah, negative 156. Okay, last step. Okay.
Well, you divide by negative.
Good. Divide both sides. Very good. X is 3. How about that?
Well, that's pretty
Good. Okay, so now we're happy. Well, it does. These are big problems. A lot to do. Okay. All right. So Eric, what do I do next? Do you suppose? What do I do next? I got x equals 3. How am I going to get my y? Plug it back in. Very good. Plug it back into either equation. Let's plug it into the bottom one. Doesn't make any difference. If I plug it in the bottom one, I'm going to get negative 10 times 3 minus 6y equals 60. And that's, now we're almost done. That's pretty easy, right? Okay? Okay, so I get negative 30, right? Minus 6y equals 60. What next? Dylan, what's next? What's the next step here? Okay, I either want hands, or if I'm asking somebody, I'm asking them for a reason. Okay, yes, sir. Add 30. So if I add 30 to both sides, I get negative 6y equals 90. Now what? And so I got my other answer, didn't I? y equals 90 over negative 6 is
A negative.
negative 15. Good. X is 3, y is negative 15. Done. Okay? Okay. All right, does that make sense? Okay, got one more. One more. Not like this, different. Okay, now I'm just telling you, it's not, everybody's got to compose themselves and you got to really focus. This next one is harder than that. So, but once you've done one of it, if you can get your brain to kind of put all these pieces together, you can do this. There aren't that many steps to this. Okay, there's the next one.
Holy crap. Okay, so exponent.
Yes, exponent. Looks pretty intimidating. It does. Yeah, this is big time stuff we're doing here. This is, we'll do a lot more of this next year, but this is big time stuff. Okay, so. Okay. Somebody help me. Dylan, help me out. What's an angle relationship here? 1 and 2. What do I know about those two angles? Say it again. They're angles. True. Okay. Is there a relationship we know between 1 and 2? Alternate interior. Okay. What are they? But can I come up with an algebra equation? They're congruent. They're equal. The measures are equal. Good. Okay. We know that because if parallel lines, right, are cut by a transversal, then alternate interior angles are always congruent. Good. Okay, so we can set up an equation. Angle 1 equals angle 2. So we get 6x squared plus 2x minus 91 equals 7x squared plus 15x minus 51. Okay, anyway, up here. So we got this quadratic equation. Now you have not seen this. This is new. What do we do with this? As we're going to learn next year, we do a lot of stuff with this. When we want to solve an equation that's quadratic, meaning it's got x squareds in there as well as x's, our strategy is to put it into what's called standard form. We're going to set it equal to 0. So we have to get all the stuff on one side. But there's one thing we definitely want to be careful about when we do that. I could push the stuff either to the left or the right algebraically. They're both doable. But I want to have a positive number of x squareds when I'm done. So which way am I going to push everything? Okay, to the right. Good. So we're going to subtract all this stuff. We'll subtract 6x squared from both sides. We're going to subtract 2x. And we're going to add 91. So all this stuff cancels, and I just get a 0, right? On the other side, 7x squared minus 6x squared is x squared. Good. 15x minus 2x. Okay. And negative 51 plus 91? 40. Good. Plus 40. Okay, so now we've got a quadratic equation. Let's go ahead and flip this around though. So it's starting to look familiar, I bet. So this looks like something we've dealt with earlier. Okay, there it is. Okay, I didn't want all that stuff to be there, darn it. Okay, so that's what we got. Okay. Well, I know they're not always fun, but we're going to do a lot of this next year, so this is important. Okay, if we've got a quadratic equation in standard form. Yeah, I'm going to ask politely one more time for everybody to stop, just focus here. Okay. When I've got something like this, we had a trick. Now, we talked about this earlier. I'm not going to spend a lot of time on this, but one of the important things we said about this was, if I want to solve for x here, I can't do this the same way that I solve for x in other situations. because I have an x squared term and an x term. So I can't just isolate x. I can't get it by itself because there's no way to somehow pry that x out of the x squared and combine it with that x that's 13x. Can't be done. So my other strategy was, if I could break this apart, if I could unfoil it, and I could write it as a product of factors instead of as a sum of three terms, that makes things easier, right? And that's what we call factoring.
So back
If I can unfoil it, right? If I unfoil it, remember what the FOIL process tells us. First times first has to equal x squared, right? So that's going to be x, and that's going to be x. And then the question was just, what are the numbers that I could come up with, or can I? We can't always, but in this case we can. Can we come up with two magic numbers that multiply to what? Multiply to 40, but add to 13. Very good. 8 and 5. How about that? So we get plus 8 plus 5, right? 8 and 5. Question? Okay, let me go back and say that again. Okay, our goal here. Our goal is we want to come up with two numbers. When I'm unfoiling this, I know that if it works, the template is going to look like this, right? If it works. Because, okay, now, and why are we doing that? Good question. We're doing that because if I can unfoil it, I know that a product of two factors can only equal 0 when I'm actually multiplying by 0, right? The only way I can multiply stuff and get a 0 answer is if I'm multiplying by 0. AJ, what are you doing? Get that back, please. Sorry. And so, right, so then I've got two factors up there that are being multiplied. If the answer is going to be 0, then I could just ask the question, what x value is going to make the first factor equal 0? And that's easy to find, and that's one of my answers. And then what x value makes the second factor 0? And that's my other answer. Yes, ma'am? Yes, ma'am. Okay. So that's why I'm doing this. Good question. That's why I do this. Now the question is, what are the numbers, right? I want to come up with the numbers. When I FOIL stuff out, and just look at an example real quick. If I FOIL out x plus 2 times x minus 3, if I FOIL that out, first times first is outside times outside is good. Inside times inside is good. And then last times last is, but then I could combine those, couldn't I? Right? And so that's what we're trying to do. We're trying to come up with numbers. We're trying to come up with numbers that we could do this with and get this result when I add up like terms. Okay, and the way, question?
So how come we FOIL on the last?
Because the last problem we did? Okay, because the last problem, if we look back at this last one, it was a totally different kind of problem. The last one, our equations didn't have squares in them.
Okay, so only time we do FOIL with that square?
Right. We're going to FOIL and unfoil when we're dealing with quadratic stuff. Exactly. Okay? Okay, so now then the question becomes, can I find the magic numbers that would work? So in order for them to FOIL out to this, what has to happen is the two numbers that would work have to multiply to the constant, so they multiply to 40, and they have to add to whatever number is being multiplied by x, so positive 13 in this case. Right? And in this case, it's 8 and 5. Right. Now, next year, you might be wondering, well, what if it doesn't work? And it doesn't always work. If you can't find two magic numbers, then we have to go to plan B, which we'll learn next year. We don't know this year. Okay? But for now, this is our first line of defense. Our first strategy is always to try to factor things. So we get plus 8 plus 5.
It didn't matter which side it was.
Doesn't make any difference. No difference. Okay, and then all we got to do to get our answers is we just have to ask the question. Now, if I know that, x plus 8 times x plus 5 equals 0, only way that can happen is if either x plus 8 is 0 or x plus 5 is 0. What's the x value that we could plug in that would make x plus 8 equal to 0? Negative 8. So x equals negative 8, or what's that one going to be? Okay, which one is the next question, right? Yes, ma'am. Okay, good. So let's go back and look at the question. So the question says, now there's some instructions up here that we skipped, but now we got to read them. It says, enter only the solution that is reasonable within the context of the problem. And what we mean by that is, in the picture here, if angles appear obtuse, meaning what? Bigger than 90, okay. Then assume they are, and if angles appear acute, assume they are. Angles 1 and 2 look to be what? Acute. Okay. So then we want to pick the x value that when I plug it in is going to give me back a correct answer, an acute answer, right? Yeah. So if I put in negative 8, for example, so let's try that. If x equals negative 8, then the measure of angle 1 equals 6 times negative 8 squared plus 2 times negative 8 minus 91. Now, if we do that math, we'll do this quick here. What's negative 8 squared? 64. What's 6 times 64? What, 384? 384 minus 16 minus 91. So that's going to be a ridiculous answer, isn't it? We can already see I'm going to get an answer that is really big. That's way bigger than 90, right? So we know that x equals negative 8 doesn't work. Now let's make sure one of them does, though. Let's try negative 5. If x equals negative 5, we're going to get back the measure of angle 1, which is the same as 2. It doesn't matter which one we pick. The measure of angle 1 would equal 6 times negative 5 squared plus 2 times negative 5 minus 91. What's negative 5 squared? Times 6? 150. 150, and then I get minus 10 minus 91. That's minus 101, so I just get 49. That's good, isn't it? That's reasonable. So then we know that the correct answer that Moodle wants is negative 5. Okay, that's hard. There's a lot of stuff there. That's big time math. Now you can do okay on the test, really, without getting either of those right. But to get that A, you gotta know how to do those. Okay. All right. 205.